So far away. Again say,
The
what is
distance from
wavelength?
crest to crest or show is called wavelength, or the distance traveled by a wave horizontally in the direction of a propagation for a complete cycle.
So again you listen. It is trough, not
Oh,
trough.
trough.
Trough, trough. Say trough, trough. Say trough.
Trough.
Crest, trough. So the distance from crest to crest or trough to trough, right? This is
Trough to
called
trough.
wavelength. And there is another definition. Starting of the wave to the end of the wave, right?
Yes, sir.
So you understood it.
Yes, sir.
And wavelength, what is the unit?
Lambda.
Lambda, lambda. Then we have amplitude, right?
Yes,
We
sir.
also discussed amplitude, right?
No, sir.
In your notes, it's not written amplitude. Did you check?
Yes, sir. Till wavelength.
Till wavelength you wrote. Okay, look here now amplitude. Write the heading amplitude
Yes.
and draw this diagram. After drawing this diagram, then you label some other points like this position. This is rest position.
Yes, sir.
It is rest position. You label it here. Rest position. This one. Rest position. So the particles are vibrating from this rest position, right? Did you check the recording?
Yes, sir.
So in your recording, I was checking that amplitude was discussed, but why you did not take the notes, I don't know. Amplitude and frequency both are discussed. I just checked now in the recording. This way you label. So in amplitude, we have displacement of the particles from the rest position. In this rest position, there are lots of molecules, right? So
Sir.
some molecules are vibrating more and some molecules are vibrating less. And this vibration of the molecules is called displacement. Displacement is going upwards and downwards, right? If like you are sitting in one place and from there you are moving, that is called displacement, right? So
Yes,
these
sir.
particles are also displaced from this rest position upwards. Some
Yes,
particles they have less energy, they are having less displacement. More energy particle they have more displacement. Okay,
yes, sir.
and maximum displacement is amplitude, the middle one.
Amplitude.
So in a complete wave we have two amplitudes. Okay, for the upper cycle we have one amplitude, for the lower cycle
But the lower
crest,
cycle have another.
crest. This is crest, the upper one. This is trough, right? So for the crest we
Yes,
have one
sir.
amplitude, for the trough we have another amplitude. And after drawing is
Another
done, then you
amplitude.
write this definition. Okay?
Sir, which definition of amplitude?
Sorry?
Sir, amplitude definition after drawing?
Yeah, it's written here. After
Yes, sir.
drawing is complete, you write this definition. It's written here. Is it clear?
Yes, sir.
Done. So what is called frequency?
The number of complete waves or cycle per unit time is called frequency.
Okay, then what is called amplitude? Just before
Sir,
frequency.
amplitude.
Yes,
The
yes.
minimum displacement of vibrating processor from their rest position is called amplitude.
So in one complete wave, how many amplitudes are there?
Two.
Two amplitudes. Okay. So one crest we have one amplitude and one trough we have another
Two plus
amplitude,
two
right?
and one another amplitude.
Okay. So for crest we have one amplitude, for trough we have another one, right? So we are
Yes,
done
sir.
with amplitude and frequency now.
Frequency.
Yeah, very good. Now we are going to next one. You see here we have three waves, right? Look, one of the wave has less number of cycles. This one has medium number of cycles, and this one has
And this
highest
one
number of
has high number
cycles.
of cycles.
Time is given same for all of them. That's why this one has low frequency, medium frequency, then high frequency. So what
High
does it mean?
frequency.
If the number of complete cycles are more, then there is more frequency, right?
More frequency. If
Is
there
it
is less,
clear?
then less frequency. Yes, sir.
So then you write speed. Speed, huh? Speed, you give the heading, then you just write the formula. Speed equals frequency into wavelength.
Frequency into wavelength.
Then you write in short V equals F lambda. Lambda, huh? Lambda. Can you pronounce lambda?
Yes, sir. Lambda.
Lambda. Okay? This way, lambda. So V equals F lambda. It is the formula of speed. If you know frequency and wavelength, you can find the speed. Okay?
Yes, sir.
Now we are having longitudinal and transverse wave.
Sir, I will write the SI unit of speed.
Speed you know, right? Meter per second.
Yes, meter per second.
Yeah, for wavelength it is meter, for frequency it is per second. So it is meter
Second
per second.
per second.
Is it clear?
Yes, sir.
Okay. So it's done, right?
Yes, sir.
Longitudinal and transverse wave. So you write the heading longitudinal first. Longitudinal wave.
Yes, sir.
Yeah. Longitudinal wave. Yeah. Longitudinal and transverse wave we are having, right?
Sir, when our final exam, half yearly exam will be appear this time?
Okay,
Jan,
last year when it was?
December. But this time
So,
to the session has started a late.
yeah. So this time also we are thinking about December. Hmm.
So online.
Yeah, it will be online or offline. It depends on the government, right?
Yes, sir.
We are not sure about it. Maybe the school will be opened or it will be
Close.
still closed for the corona. We don't know. We are thinking that it will be open, but actually parents, they will send their kids or not. Allah knows the best. Parents are very much
And Bangladesh
cautious
don't
about
want
their.
to take risk like America.
Yeah,
what happened in America only.
yeah. So did you write longitudinal and transverse
Yes,
wave?
yes, sir.
Both you wrote or only one you wrote?
Sir, both.
Both longitudinal and transverse wave. Now
Answer.
you try to understand it first, then you label. Huh? First, you see here we have the same thing. Huh? For both the diagrams, we have the same spring, right?
Yes, sir.
Isn't it?
Yes, sir.
But in the left side one, the spring is compressed and expanded, right?
Yes, sir.
So because of this compression and expansion, the spring moves, spring particle moves forward and backward, right?
Yes, sir.
And the energy transfer is happening till to the end, end of the
Yes, sir.
spring. So the energy direction, we are giving the energy here, but energy is transferring to the right side.
Yes,
Is
sir.
it?
Yes, sir.
So what can we say? If the transfer, if the particle's vibration is forward backward with the energy transfer direction, then it is called longitudinal wave,
Yes, sir.
right? Then
Yes, sir.
for this one we are having the up and down, huh? The vibration
Yes,
of the
sir.
particle up and down, and energy transfer is right side. Okay,
Yes,
so
sir.
we can understand if it is upper or lower vibration. In
Or
both the cases the
yes,
energy
sir.
transfer direction is perpendicular or 90-degree with the energy transfer direction, right? The wave particle vibration
Yes, sir.
is 90-degree with the
Yes,
energy
sir.
transfer direction. So it is called
Yes, sir.
transverse wave. So what you will do,
Yes, sir.
you will draw these two spring and these arrows, red color arrows you will draw, and you
Yes,
will
sir.
label here energy transport. Again for this spring we will label these two
Energy
arrows and
transfer.
energy transport. And this one is transverse wave, this one is longitudinal wave. That's it. Okay,
Yes, sir.
finish the diagram, then we will define what is called longitudinal, what is called transverse. I am writing here when particles vibration or you can say movement is forward and
So I will also write coil moves left and right. This one.
no, nothing, only draw coil, label the arrows and energy transport. That's it.
Yes, sir.
It is forward backward we know, and the definition is also saying us, right?
Yes, sir.
Forward and backward in bracket you write parallel with energy transfer direction is called longitudinal wave. So is it clear? It is called
Yes, sir.
longitudinal wave, and here we'll write the opposite. Uh, when particles vibration, you can make it also. You understood already, so you can make it. When particles vibration.
It's longitudinal waves definition.
Left side one is longitudinal definition, and right side one I'm writing transversal. When particles vibration is up and down. In bracket you write perpendicular, polar, or 90 degree, right?
Yes, sir.
90 degree with energy transfer. Direction direction is called transverse wave. Is called transverse wave. When particles vibration is up and down, perpendicular or 90 degree with energy transfer direction is called transverse wave. So are you done with the example? Are you done with the definition?
The longitudinal wave done. Now I'm writing transverse wave.
Okay, transverse wave you do.
When particles vibration is up and down. Is up and down.
Examples, longitudinal examples
Perpendicular
I'm
on
giving.
90 degrees.
Sound wave, then seismic
When
wave,
energy transfer direction.
seismic wave, then spring spring is moved.
So I've written both the definition.
Yeah, after writing both the definition, I am writing the examples. Examples of longitudinal wave, you write sound wave, seismic P wave, a spring is moved forward and backward, right?
It's longitudinal for example.
Yes. So if you have a space
Sound
there, you
wave.
write longitudinal wave examples this way. Otherwise, you write here longitudinal examples. Okay.
Yeah.
Anywhere you can write, etc. Then transverse wave example.
A spring is moved forward
Memorize
and
them.
backward.
Memorize them.
Yes.
Water waves. Then light. light wave, all electromagnetic waves. Magnetic
etc.
wave, all the electromagnetic waves. Then um, seismic S wave. Okay, seismic S wave. Today we got one example of seismic S wave in our worksheet when we discussed in school. Okay, uh, were you present till the last today, or you disconnected?
Yes, sir.
Seismic S wave. Then we have a spring moved up and down, right? Up and down. uh, and move up and down where energy transfer is right side.
FY.
Okay, so
Yes,
these
sir.
all are examples of what? Transverse waves, right?
Yeah.
So longitudinal and transverse wave, you are clear, right?
Yes, sir. Yes, sir.
Any questions here?
No, sir.
You understood everything.
Yes, sir.
We can go to the next part. Okay, so you see here longitudinal waves, we have compression and rarefaction, right?
Yes, sir.
Is it clear?
Yes, sir.
So
Yes,
we
sir.
are having compression and rarefaction. Compression means the particles are closer, right? And rarefaction means they are far away, right? Is it clear?
Yes, sir. Yes, sir.
Then reflection, reflection.
Yes, sir.
Write the heading reflection. After writing the heading, you draw this diagram.
Refraction.
Reflection. You see the heading written,
Oh, it is
reflection.
refraction.
So you draw this diagram.
I've written the heading.
Huh? Yeah,
Yes, sir. I'm drawing.
after writing the heading, you draw this diagram. Nicely you draw. You see, we are having the wavefronts, parallel wavefronts coming, then returning back. Okay, this is called
Yes, sir.
reflecting. Returning back in the same medium.
Uh, When a wave return the to
Yeah, if you are done, right, then you write this definition. When a wave bounces off and return to the same medium, then it is called reflection, right?
yes, sir. Then it is called refraction.
So your labeling and writing done.
Then yes, sir.
Okay. Then you write some other information. After reflection, the speed and wavelength
And wavelength
of reflected wave
of reflected wave
remains
remains same.
same, remains same.
Same.
Okay,
Yes, sir.
is it clear?
Yes, sir.
Now we are going to write law of reflection. You
Yes, sir.
write the heading law of reflection. Then you draw this diagram.
Sir, what is the law of reflection diagram?
Yeah, you write the heading law of reflection. After
Oh,
writing all this, done, then you write law of reflection, then you draw this diagram.
so the normal I add that one.
Yes, yes. Normal, I'm writing the definition what is called normal. What is called normal? I'm writing. It is an imaginary line perpendicular on the reflector. Okay. So imaginary
Okay.
line normal is perpendicular, making 90 degree with the reflector. Okay.
Yes, sir.
Then you write law of reflection. Reflection. What is law of reflection? It is angle of incidence incidence equals angle of reflection. Huh?
Yes, sir. Law of reflection.
Angle of incidence equals angle of reflection. Or we can say I equals R, right?
Yes, sir.
Is it clear?
Yes, sir.
And you note down one thing, that is, we always label angle of incidence and angle of reflection
Yes, sir.
from the normal. Okay, we started from the normal.
Yes, sir.
Is it clear? Normal from the normal to the incident ray. This is
Yes,
angle
sir.
of incidence. The normal to the reflected ray, it is angle of reflection.
Reflection.
So you note down this point. This is very, very important.
Yes, sir.
This way, give star. Angles are always measured from the normal. Okay,
Yes,
angles are always measured from the normal.
yes,
We already got, you know, all the things. What is related
yes,
to
sir.
reflection?
Yes, sir.
So reflection is done. Now we will do refraction. Are you done with drawing and writing everything?
Yes, sir.
Oh, it's one. Then you write the heading refraction. Huh?
Yes, sir.
First understand what is called refraction. Huh? Yeah, try to understand it. Refraction means bending of wave.
Reflection. Yes, sir.
Refraction means bending of
Bending of wire.
waves. Ah, bending means is changing the direction, right?
Yes, sir.
Look in the diagram, there is direction of incidence waves coming straight.
Yes,
Then
sir. I'll
it's
draw the
going
diagram.
to, yeah, wait. Draw the diagram later. Huh? First you understand. You see in the direction of incident waves, it is going straight. Then
Yes,
when
sir.
it is going to the straight part, that is deeper
Yes,
region of
sir.
water, deep water.
Yes, sir.
Okay, and when it is changing the direction, that time it is shallow water. That means it's not that much deeper, it's less deeper. So
Yes, sir.
when water waves are going from deeper to shallow region, that time it bends. Why is bending? Because its speed decreases.
Yes, sir.
Is it clear?
Yes,
And
sir.
as speed decreases, we have the wavelength also decreases. Look, the
Yes,
plane
sir.
wavefront we have here, there is gap, bigger gap.
Yes, sir.
This gap is labeled with lambda 1. That means this
Yes,
wavelength is greater. We can say
sir.
lambda 1 is greater than lambda 2, right here.
Yes, sir.
After refraction, you see the lambda 2, it is smaller gap. So
Yes,
this
sir.
one is showing us smaller wavelength.
Yes,
Okay, if the speed decreases, that means wavelength also decreases.
yes, sir.
Now you draw this
Yes, sir.
diagram. Huh? Draw this diagram, only label this part, lambda 1, then direction of incident waves, then direction of refracted waves, then lambda 2. That's it. Okay?
Yes, sir. Yes, sir.
And here you just give arrow with this is deeper region
Yes, sir.
and this is shallow. Huh?
Yes, sir. I will draw the diagram for now.
Yes, yes. Draw the diagram. Quick. And after drawing is done, you write the definition. When water waves travel from a deeper to shallow region. When water waves travel from deeper to shallow region, then it bends. This incident is called refraction, right?
Yes, sir.
This bending is called refraction. Okay,
Yes,
so
sir.
in refraction, so here you write here for the same source of wave, for the same source of wave, frequency is always
Yes, that
same.
is how.
For the same source of wave, frequency is always same. Okay, we have a formula. Can you remember?
Yes, sir. Which one?
This one, V equals F
Equal
F lambda, right?
F lambda. Yes, sir.
So if frequency is same always, huh? For the same source, the frequency is always same. Then if the wavelength decreases, that means speed also decreases, right?
Yes, sir.
Like if there is wavelength decreases, that means speed decreases, right?
Yes, sir.
So here we can write so if are you writing the formula also? Whatever I'm writing, you write everything. So
Yes,
if
sir.
uh, if the if the wavelength decreases, if the wavelength decreases, then speed speed also decreases. So you understand this explanation from the
Yes,
formula?
sir.
We have to understand it. Like frequency is same. So if the wavelength is less, then the speed is also less, right?
Yes, sir.
So is it clear?
Yes, sir.
Okay. So we are done with reflection and refraction together, right?
Reflection.
Now we have the last part. Last part of the topic.
Today
Right? Huh?
the notes will be at end. Today the chapter will be finished except
Yeah,
worksheet.
yeah. By this one we are done. We are at the end. So can you write this heading, experiment to show reflection of
And
sound?
show reflection of sound.
Yes, yes, write this heading. Yeah, can you read?
Yes, sir.
Yeah, please read.
Some activities to produce reflection of sound. If we clap our hands in a street sounded by high yielding buildings, will hear an echo. Shouting or clapping in a canyon also gives an echo. An echo sounder is used to detect the shaped and underwater objects like shoals of fish and wreck. Ultrasonic scenes are used to check on unborn babies.
Okay, so these are the uses of reflection of sound, right?
Yes,
So we
sir.
understand that sound is reflecting back, and if you can also understand it, if you are changing your house anytime and your house is
Yes, sir.
without any furniture, if it is that time you clap or you make any sound, you will hear that the reflection of sound is coming, echo is coming from the wall. Okay, so
Yes, sir.
the sound can reflect back. You got the
Yes,
idea?
sir.
Water wave
Yes,
can
sir.
reflect back. Then also what? Light wave can
Hello.
reflect back,
Hello.
right? The light wave can also reflect back, right?
Light waves can reflect back.
So it is the
Yes, sir.
experiment to understand that sound wave is reflecting back, or it is having the reflection of sound. Okay, so here we
Yes,
have
sir.
a board, and then we have here cardboard tubes. At this end, we are giving one clock or buzzer or any sound source we are giving.
Yes, sir.
And if we are maintaining the angle, angle of incidence and angle of reflection are equal, then you can hear the sound. If you are changing the place of this
Yes, sir.
cardboard tubes, then it's not maintaining the law of reflection, right? This angle will be
Yes,
greater.
sir.
Then you cannot hear the sound. So you draw this diagram, quickly.
Yes, sir.
Draw and label all. After drawing is done, you label this way. So here we are getting, if I'm writing the notes, if we change the position, if we change the position of ear or sound source, then we will not be able to hear sound. Then we will not be able to hear sound, which proves sound obeys law of reflection. Law of reflection. Okay,
Yes, sir.
are you writing?
Yes, sir.
Drawing is done.
Yes, sir.
So write the notes I gave you correctly. Huh?
Yes, sir.
Take your time and do it correctly.
Law of reflection.
Okay, done.
Yes, sir.
So we are done with the topic. Huh? Now
Yes,
I
sir.
will upload the worksheet on this
Yes,
topic and you try it. Huh? This is your homework. At least you try the MCQ part. Okay.
yes, sir.
If you try, then you will be
What,
able to
sir?
do. If you try, you will be able to solve some questions, right? MCQ part only you try. Okay. Parabi,
Yes, sir.
only try
Okay,
the
sir.
MCQ part and hope if you try, you could be able to solve some of the questions.
Yes, sir.
Okay. So thank you so much. Huh? Parabi.
Yes, sir.
Hello, Parabi.